So this problem, minus the fact that it should have told you that the two pyramids were similar, right? To figure out the volume of pyramid B, you have to set up and find your scale factor, okay? How do I find my scale factor? My K. Okay, we're going to put this as our numerator, this is our denominator. So it would be 6 over 3. Does that simplify? 2 over 1. Do I use my scale factor in my proportion? Do I use 2 over 1 in my proportion? Thank you. Why do I cube it? What are we comparing here? Volumes, right? When you compare volumes, your scale factor needs to get cubed. So let's cube. Let's write K cubed. What's 2 over 1 cubed? What? Now you realize what you did wrong on the test, right? What's 2 over 1 cubed? What's 2 cubed?
8.
What's 1 cubed? So it's 8 over 1, okay? That's what we're going to use when we want to compare for the volumes. So now we set it up. It's going to be 8 over 1 equals, did we know the volume of the numerator? We don't. So we're going to make that our variable. That's what we're looking for, is the pyramid of the volume of pyramid B, okay? Do we know the volume of the denominator figure? It's 10. What do I do from here? What's 8 times 10? 80 inches cubed. Talk to me. What questions do we have? Myron, put it away, please. This guy, let's write, oops. Pieces of information about a cone, okay? It has a vertex. Where's that vertex? At the tippy top, okay? It's that point at the very, very top. Now, keep in mind, could cones be shaped or like facing the other direction? Yes, so the vertex could be on the bottom, okay? So in our case, the vertex is that point at the very top. Your slant height, guys, this is super important. Your slant height is different than your height. Can anyone look at this figure and explain the difference between slant height and regular height? Yeah?
Height is from the base all the way to the top.
Very good. Height is from the base all the way to the top, and it forms what kind of angle?
A right angle.
A right angle. What is slant height? I heard someone said it looks like it's slanted.
The height or like the side.
Very good. It's the height along the side, okay? It is a slanted height, hence slant height. We Gucci? Okay. Lateral surface, guys, okay, is the surface around your cone, not including the base, okay? And your base is the circle on the bottom, okay? So, guys, your lateral surface, right, is like, imagine an ice cream cone. Do you put a lid on an ice cream cone? Why not? What goes inside of an ice cream cone? Ice cream, right? So imagine that like an ice cream cone is your lateral surface area, right? It's the area around your cone, not including the lid of the cone, okay? I like to call it the lid. It's just the base or the bottom or the top of your cone, okay? All right, so now we're going to talk about the surface area of a cone. The surface area of a cone, right, that's the area around the cone, has two components. It has a lateral area and then the area of the base, or capital B, okay? The lateral area of your cone, this is the new formula, you probably want to star this one, is pi r times L, where L represents the slant height of the cone, okay? That's that slanted height that goes up your cone. Now, the surface area, right, the area of the entire cone, okay, is going to be pi r squared plus pi r L. These are just fancy ways of saying it's the area of the base, capital B, because our base was, again, what shape? A circle. So it's pi r squared for the area of it, plus this pi r L we got from the lateral area. So when you add both of those together, capital B, the area of your base, and your lateral area, you will get the total surface area of the cone, okay? The surface area of the whole thing. Is area the same as volume? No. What's different? Very good. Area is two-dimensional and volume is three-dimensional. So area is like if you were to take a sheet of paper and surround your cone, how big does that sheet of paper need to be? Volume is how much water, how much ice cream would fit inside of that cone. Does that make sense? Okay. It's three-dimensional versus two-dimensional. Okay. All right, now we're going to talk about the volume of a cone. It is very similar to the volume of what other figure? A pyramid. Very good. It's got that 1/3, okay? It's got the 1/3 times the area of the base times the height. But again, guys, all of our bases in a cone are a circle, so you can also rewrite the formula as 1/3 pi r squared times the height. And it says capital B is the area of the base, and H is the height, and R is the radius of the base. Guys, do we use the slant height length in the volume of a cone? Does this formula use L? No. Okay, you have to remember that. Slant height we use for area. Height, like the height from the top of the cone to the bottom, is what we use for the volume, okay? That's probably what most students get confused on, okay? Is they'll use the slant height for the volume of a cone. Thank you, Sean, for paying attention. All right, so let's do an example, okay? We're going to use this figure to find capital B, capital LA, capital SA, and capital V, okay? And we're going to identify what each of these represents. What does big B stand for? Okay, area of the base. Let's write that down. This is the area of the base. And what shape is the base of this? It's a circle. How do we find the area of a circle? Pi r squared. Very good. So we're going to do pi r squared, not times height yet. Whoever said times height, remember that's when we add that third dimension, that's when we're talking about volume, okay? Do we know the radius? Why is it 5? What? That's half of the circle, right? So 5 is your distance from the center of the circle to the edge. So we're going to replace this. It's going to be pi times 5 squared, which would be 25 times pi. What do we get? 78.5? Can someone confirm with Christian?
Yeah.
Yes.
When you do
Yep.
pi r L, what is L?
We'll get to that in a second, okay? 78.5. What units does this guy get? Why squared?
Area.
It's area, okay? Don't forget, areas are going to get meters squared. What's going to get cubed? Volume, okay? All right, what does LA stand for? Lateral area. This is the new formula. You don't have to have it memorized yet, but what is the formula for lateral area? One half pi r squared times height. That's the volume formula. Yeah, Kristen? What? Pi r squared? Ooh, that's surface area. Pi RL, very good, okay? Lateral area, remember, is just the area around the cone, not including the base, okay? Not including the base. So, pi RL, what does L stand for? Slant height, right? What is the slant height? It's 8, very good. So we're gonna go ahead and write pi times, what was the radius again? 5, and then 8. 168 point what?
No, I said 125.
125.7? Can someone confirm that?
I confirm.
Confirmed? Cool. Now, surface area is what? Kristen? Yep. Very good. But guys, we just found both of those. So surface area, very good, Dylan, is we're just going to add the area of the base plus the lateral area. That will give me the total surface area of the entire cone, okay? So we're going to write that it's going to be capital B plus LA, your lateral area, and we just add 78.5 plus 125.7. Should be like 204.2 meters squared. Cool beans? Talk to me. What questions do we have? Come on, I'm not that good of a teacher. You guys have to have some questions. It's easy? Okay, cool. You didn't just jinx it, but I will tell you the volume is going to be slightly harder to understand. But we're good so far? Okay. Volume. What is the formula for volume? Yes. We do not. This is just going to be on the final, okay? 1/3 base times height.
Or pi r squared h.
Yeah, let's go ahead and substitute it in. It's going to be 1/3 pi r squared times the height. Okay? Do we know the radius? Cool. Do we know the height?
No.
Ah, we do not. So we're going to put an H there. Does anyone see a shape that maybe we could use to our advantage to help us find the height? There is a triangle there. What kind of triangle? A right triangle. Very good. Yes, Dylan. We can use the Pythagorean theorem. Can you set it up for me, Dylan?
5 squared plus just do x squared, I guess.
I'm going to put H because that'll be my height, right?
8 squared.
Very good.
Wouldn't you just, 25 plus h squared equals 64 squared.
Yep. Mm-hmm.
25.
Come on, you don't need a calculator for this one.
39.
39.
And then, no, I forgot.
What do we do from here, guys? Very good. Take the square root of both sides. So we get H equals square root of 39. Don't plug it into your calculator yet because it's going to round. Like if you round it too early, you're going to be off by just a little bit, okay? So we're going to take this value. We're going to plug it in over here with the radius. What was the radius again? So it's 1/3 times pi times 5 squared and then times the height, which is the square root of 39. Plug it all in together into your calculator so you don't round too early. Let's see what we get. 25 times pi divided by 3 times the square root of 39. 163.5.
Yeah.
Heyo. And that should be meters what? Cubed. Why cubed? It's volume. Now I should have some questions. Daniel.
Wait, what do we do with the 1/3 base times height?
What? Oh, so remember, Daniel, your base, right, is a circle. So we replace that with pi r squared. Right? This is our base, pi r squared. It's a circle. Capital B represents the...
It's not like the formula is 1/3 pi r squared h. It's not like 1/3 base height equals that.
What?
Is like the formula you use 1/3 pi r squared h.
Yeah, so these are the same, right?
Oh, okay.
I'm just replacing capital B, which is representing the area of my base, with pi r squared because that is the area of a circle, right? And my base for a cone is a circle. Does that help? Okay. Sophia? Oh, it's 163.5 meters cubed. Hannah, did you have a question? Oh, yeah. No, you're good. What other questions do we have? Christian? Yes. No questions? Okay, superstar. If there's no questions, then do example 2. All right, your base should have been 452.4 meters squared. Your lateral area should have been 490.1. Your surface area should have been adding those two together. 942.5. And then the volume should have been, this is going to be 5 squared, 5 times 5 times pi times, no, it's 12 squared times pi and then times 5 and then divided by 3. 754.0.
I got them all right.
Got them all right?
All right.
Let's go. Yes, because that shows me that you rounded to the nearest tenth. Okay? Because if you just write 754, I assume that you rounded to the nearest whole number. Okay? Yes. Thank you. German, you can go now if you need to. Guys, we're going to go over the volume one. So you agree that volume is 1/3 pi r squared times the height. Did you get that far? Heyo. The height, though, remember, this is 12. This was unknown. Did you use the Pythagorean theorem? Okay, so you did a squared, or your height squared, plus the 12 squared equals 13 squared.
Oh, I did 24 squared.
Oh, don't forget you have to use the radius here, okay? 24 is the length of the whole thing. Oh, you both use the, okay. So set it up like that and you should be able to get the right answer, okay? You should get that a equals 5 and then use that 5 as your height of the cone. Cool beans? Okay, 2 more examples, people, and then I'm done, I promise, okay? All right. Cone A and cone B are similar. That means I'm looking for scale factor, okay? Nothing changes. So my K value, how am I going to find my K value? What do? Good, 9/3. That means this will be my numerator. This will be my denominator. Make sure you label them so you're consistent. So it's going to be 9/3. Do we know 9/3? 3/1. What do I do next? Cube it. K to the 3rd power is 27/1. Now what do I do? What do I do next? 27/1 equals, I cubed 3/1. So 3 to the 3rd power is 27. What'd you say, Gio? V over 15 pi. Don't forget the pi, okay? Why V on top? Because that's the numerator figure, right? We have to be consistent. What do I do now? Cross multiply. What's V times 1? And what's 27 times 15? 405. 405 pi. When you multiply it out, what do you get? 1,200 something? You can leave it in terms of pi. But let's say it was a multiple choice and it had some answers that were not in terms of pi. Make sure you can multiply by pi. I got 1272.3. Yeah. What units does it get? Feet to the what power? Feet to what power? 3rd. Why? It's volume. Bryson, is it bad? Wait, hold on. Leave it open. Oh. Last one. So we have a composite solid. What does a composite solid mean again? It has two. Very good. It has two solids there. What are my two solids here? What's the one on the bottom? That's a cylinder. Very good. And the one on the top? Good. And we'll say number 2 is a cone. Which one do you want to find the volume of first? Cylinder? Okay. Let's do the cylinder first. What's the volume formula for a cylinder? Volume equals pi r squared times the height. Dylan, you didn't even need a formula sheet for that one. You're crushing it, dude. Okay. Do we know the radius? It's 3. So volume equals pi times 3 squared. What's the height? 10. What do you get? Multiply it, peeps. Multiply it. 90 times pi, which is 282.7. 282.7 centimeters cubed. No. That's for the cone. Okay? For the cone, now our formula changes. How does our formula change? It's a third the volume of the cylinder. Okay? So pi r squared times the height. Our radius is the same or it's different? The radius is different. What's the radius of the base of the cone? It's still 3. Okay? Remember, the base of the cylinder, do you see how it matches with the base of the cone? So that radius is not going to change. But are the heights the same? No, the cone is less tall. Do you guys agree? By how much? What's the height of the cone? The height of the cone is 5. So we multiply this. This is going to be pi times 9 times 5, and then divided by 3. 47.1. And then it's going to be centimeters cubed. Neither of these is the answer. How do I find the answer? You add them. So the volume total, 329.8 centimeters cubed. Hold on. I have to check that. I don't think that's right. It's right. Who said my name? Kristen.
What happens if you don't know the height? Like, let's just say it says that the whole hurricane is 10 seconds. Okay.
Well, okay. Let me tell you this, Kristen. You would know that this is 3, correct? It could give you that this slant height is 5, and you'd be able to use the Pythagorean theorem to figure out the height. But there's no way that they leave both of these blank. Is that good enough for you? Okay. All right, guys, turn these in. We're done.